Hey everyone, today we're going to do a video on a tricky example with a quotient rule. So I wanted to look at one where we have the quotient rule, the product rule, and the chain rule all kind of jammed up into one. So here is our function f of x equals to 3x all over the square root of 4x squared plus 1, and we're being asked to find the critical points of f of x. And so one part of doing that is solving the equation f prime of x equals 0, as well as look for any points of discontinuity in f prime of x itself. Okay, so our first step is clearly to find the derivative of f of x, namely f prime of x. And so if we do so, I'll remind you of the general chain rule, general quotient rule, excuse me. So if f of x is equal to v over u, 3x over the square root of 4x plus 1, then f prime of x is u v prime, that is the denominator times the derivative of the top, minus vu prime, that is minus the numerator times the derivative of the denominator. And then all that over the denominator squared. And so maybe you can see right away that when we square our denominator, the square root will just cancel out. And so our denominator won't be too complicated to deal with. Okay? So if we go ahead and do that, we're going to get a big fractional piece. So we'll start off with the derivative of the top, v prime. The derivative of 3x is simply 3. And so we'll have 3 times the square root of 4x squared plus 1 minus 3x times. Now, before we differentiate the denominator, I'll remind you that the square root of 4x squared plus 1 can be conveniently written in exponent form as 4x squared plus 1 to the power of 1/2. Okay, this is going to come in handy, and we're going to use this several times. So 3x times the derivative of this piece, and using our typical power rule, the 1/2 will multiply out front to become the denominator. We'll still have 4x squared plus 1, and now the power, the exponent drops down by 1, and so 1/2 minus 1 brings us to negative 1/2. And then all of this times, we have the chain rule in effect here, and so we're going to remember to multiply by the derivative of the expression inside of the bracket. And so the derivative of 4x squared plus 1 is namely 8x. And now all of this over our denominator, square root of 4x squared, all squared, right, by our chain rule general formula. And so if we go ahead and continue on our journey, we'll have 3 brackets 4x squared plus 1 minus, now let's simplify this meaty second term here. So we have 3 times 1/2 times 8. We can simplify the 8 over the 2. That's just going to be a 4, right? And now we have 3 times the 4, so we'll have 12. Now we have an x here and an x in the end, and so we'll have an x squared. And we still have 4x squared plus 1, all to the power of negative 1/2. And now all of this over the square root and the square will neatly cancel out in the denominator, and so all we have left is 4x squared plus 1 on the bottom. Now let's go ahead and clean up the numerator. Now this is a piece that makes finding the critical points a little bit easier. If I were to ask you to find the solutions to f prime of x equals 0 when we still have it in this form, that's a task and a half to do. But if we take the time to use some algebraic manipulations that are so important to developing calculus, to kind of clean up this mess, we'll see how it flows right down to a much more manageable kind of question in the end, okay? So if we go ahead and manipulate our numerator a little bit, I'll make a note that what we have here in our second term is really 12x squared. I'll just put an arrow. That second term here is really 12x squared over 4x squared plus 1 to the power of 1/2. Because that's precisely what a negative exponent does. It means 1 over that. And so if we have 12x squared attached to this, then what we really have is 12x squared over 4x plus 1 to the power of 1/2, okay? That means that our second term itself has its own denominator, okay? Now, we would like to ideally be able to combine the two terms in our numerator, but this first term here doesn't have a denominator at all. So, if we do want to combine both terms through subtraction, we need to have a common denominator, right? We've always learned that. To combine fractions, we need a common denominator. And so we could get a common denominator for our first term of 4x squared plus 1 to the power 1/2, as long as we multiply this entire term by 4x squared plus 1 to the power 1/2 over 4x squared plus 1 to the power 1/2. Okay? If we do this, then we'll get our common denominator in both terms, which will let us combine them, and it'll simplify down nicely later on. And we simply have to be mindful of how this and the top part here will kind of combine together, okay? So let's go ahead and do that. So now we'll have 3 will obviously not be changed. Now we have the square root of 4 squared plus 1 times the top part here is 4x squared plus 1 to the power 1/2. Well, that's the square root of 4x squared plus 1. That's all that is, right? And so the square root of 4x squared plus 1 times the square root of 4x squared plus 1 times the square root times itself, that's no more than 4x squared plus 1. Okay? And now we have it over our required denominator of 4x squared plus 1 to the power 1/2. Okay? And now we still have our second term, which I'll go ahead and write this way, just so we can visualize how they're going to combine together. So we still have over 4x squared plus 1 to the power 1/2. Again, I'm just bringing that negative exponent into a denominator, because that's really what it does. And now we still have all of this over our, let's say, our real denominator, 4x squared plus 1. Okay? Now that we have a common denominator up top, we can combine the two terms. Okay? So let's go ahead and multiply the 3 through our brackets, through our binomial. And so what we'll have is 3 times 4x squared, that'll give us 12x squared plus 3 minus 12x squared. We can combine them now because we have our common denominator. All of this over 4x squared plus 1 to the power of 1/2, right? And again, not losing sight of the fact that we still have this all over 4x squared plus 1. Okay, now let's continue. We're almost done. Now, in our very top numerator, we have 12x squared minus 12x squared. You see these two terms? Those will cancel out nicely. And so all we have left in the very top is a 3, okay? I'll remind you that our goal is to solve f prime of x equals 0. Having solely a 3 in our numerator is going to be very easy to deal with. And so what we'll have is 3 all over. And now we can kind of combine the two denominators into one, because what we have here is 4x squared plus 1 to the power 1/2. And in the very, very bottom, we have 4x squared plus 1 by itself, right? It is understood that when there are no exponents in sight, it is to the power of 1. And one of our exponent laws is that when we combine the same base through exponents, we add the exponents, right? And so if we combine these two denominators together, we're going to have 4x squared plus 1 to the power of 1 plus 1/2, right? The exponent of 1/2 combines to the power of 1, and they can become one sole denominator. And so if we finish it off, we obtain 3 over 4x squared plus 1 to the power of 3 over 2. So here is our f prime of x expression, okay? 3 over 4x squared plus 1 to the power of 3 over 2. Now, if we want to solve this equation to find the critical points of f of x, right, we're having this equal to 0. So f prime of x equals 0 means that 3 over 4x squared plus 1, or 3 over 2, is equal to 0, right? Are there any solutions to this equation? Clearly, there are not, right? Because there's just a 3 in the numerator, right? There's no variable at all in the numerator, and 3 can never be equal to 0, no matter what the denominator is, 3 over anything will never be equal to 0. Now, the other option we might be able to find for a critical point of f of x, because we're, after all, looking for the critical points, we could find a point of discontinuity, which would mean when the denominator here would be equal to 0. And so our function, our f of prime of x function, would be undefined. However, if we take a second to inspect our denominator, our 4x squared plus 1, there's no way this is ever going to be equal to 0. Because what we have is 4x squared, which 4x squared is always greater than 0, plus 1, which will only make it more positive. And so our denominator is always going to be greater than 0. And anything greater than 0 raised to a power bigger than 1 is clearly going to be greater than 0. And so there's never going to be any points of discontinuity, as well as there exists no solution to this equation. And so what we find is that our function f of x turns out to have no critical points. No critical points. And there we have it. Okay? So I hope this was helpful. I hope, more than anything, the quotient rule, the chain rule, the product rule, all those things are really important and really great to kind of develop your comfort level in. But more than anything, I hope this part, using some algebraic manipulations to kind of work around our numerator and really simplify it down to something much more manageable, makes the task of solving this equation far easier than it would have been if I had asked you that same question and we had stopped here. This would have been an absolute gigantic mess. But when you go and simplify it down, you see that it turns out to be not so bad at all in the end. And so I hope this provides some insight on when some algebraic manipulations are in order. I hope that even the critical points stuff was helpful. If you guys have any comments, suggestions, please let me know. Any requests for future videos, always appreciated, and thanks for watching.